Feuding Fuels, a comparison of efficiency and exhaust analysis of B10 diesel, B100 homemade biodiesel, kerosene, and ethanol. We're going to discuss the research, advantages, and disadvantages of all four of these fuels in home and agricultural settings. The defining problem is which fuel is going to be the most efficient and best for the environment, and if it's feasibly possible to make homemade biodiesel. With the rising cost of fuel and the increasing amount of greenhouse gas emissions, we wondered if biofuels were going to be a better option.
So a few of the questions were, which fuel is the most efficient and the cleanest burning? How do the fuels affect the engines? Can biodiesel easily be made at home? In an engine, is homemade biodiesel or conventional diesel more efficient, and which is cleaner burning? In other uses, how does homemade biodiesel compare to kerosene and ethanol? And what are the political and agricultural impacts of the fuels?
So I'm Brian Perkle, and I experimentally compared homemade biodiesel to B10 farm diesel, and for efficiency, as well as I analyzed the exhaust of both fuels, and I successfully made and used homemade biodiesel in a one-cylinder diesel engine.
I'm Anna Perkle, and I experimentally compared ethanol, kerosene, and homemade biodiesel in a homemade calorimeter to heat up water, and I also caught particulate matter using a coffee filter and coffee can capturing system.
I'm Tyler Frum, and I researched fuels and researched the ag and environmental impacts, and I studied how the engines work, and I talked to professionals. So what are biofuels? A biofuel is any fuel made from a biomass material, and by biomass I mean they're a renewable resource, and by renewable that means that they can grow back. So some examples are plant or animal-based materials. And the fuel must be 80% renewable to be called a biofuel. Ethanol is produced by extracting sugar from corn or a variety of other plants, and the plants undergo formation which changes them to an alcohol called ethanol. Ethanol is mainly used in cars when mixed with gasoline, but ethanol can cause gummy fuel systems or melted engine parts because it burns extremely hot. But it is very non-potent. It actually helped reduce greenhouse gas emissions by 8.4 million cars when mixed with gasoline.
And here's some of the chemical structures of it as well.
And there it is burning. To produce biodiesel, oils or animal fat are put through transesterification, where glycerin is separated, which leaves methyl esters, which is the chemical name for biodiesel. Biodiesel reduces wear on engines, but also reduces power and efficiency. In the U.S., biodiesel is actually the only biofuel to pass to complete the emissions test. And according to the U.S. Department of Energy, biodiesel provides 5.5 units of energy for every 1 unit of energy used in production, and that makes it the most return energy of any fuel approved for motor use.
And here again is the chemical formulas.
To produce B10 diesel, what you do is you heat crude oil and separate its components into smaller components, which include diesel, and then it's mixed with 10% biodiesel. And B10 diesel creates more pollution, and it's also harder on engines and more expensive, but the benefits are that it's easier to find, and it creates more power and offers better fuel economy. Kerosene is produced by heating crude oil and separating the components, one of which is kerosene. Kerosene is used for lighting, cooking, and jet fuel, but some of the drawbacks are that it creates a lot of pollution and is not renewable. Some of the benefits to kerosene is that it is inexpensive, and you can also use it as an additive to diesel-powered vehicles to reduce gelling in cold climates. Here are a few alternatives for future studies. So this is just a quick drawing I drew of a diesel engine and how it works. You have basically the main parts are the piston, the fuel injection, and the pre-chamber is pretty important, combustion chamber.
So essentially what happens in a diesel engine is the piston comes up compressing air, and the air gets so hot by the time the piston is all the way up at top dead center that the injector injects a small amount of diesel fuel, and it immediately ignites, pushing the cylinder back, pushing the piston back down, and in turn turning the crankshaft.
And in this drawing, the only difference between a gas engine would be the glow plug would be a spark plug. So that's really the only difference. So in our government system, lobby groups have a huge impact on the way legislators vote, specifically on various farm-related and energy bills. And laws that are passed on this directly impact industries in a positive or negative manner. This will ultimately affect other industries and affect the price of goods and services as we pay as end users. Biofuels are usually cheaper, which can lead to corn prices going up and oil prices going down, and this will cause a ripple effect. By that I mean when oil prices go down, there will be way less jobs in the oil industry, it could hurt jobs, but then there will be more jobs in like a farming industry. So most alternative fuels are better for the environment, which means they cause less pollution. Also, they are renewable, so we will never run out of them, like we will most likely run out of crude oil in the future. And there will also be a greater need for producers of grains and grasses for the biofuels, and their waste products can be reused.
So some of the existing solutions we could have used during this project would have been buying biodiesel, purchasing it, and we wanted to make it instead to show the simplicity and ease of making homemade biodiesel. And in addition, we read about biodiesel and ethanol and biofuels in hands-on experimentations as well as articles. And to test exhaust particles, I created a system using PVC piping that went down from my diesel engine into a bucket of water, and that just basically put all the pollutants into the water so I could measure the water instead, and then I get information about the exhaust.
And I tested for particulate matter using first visual observations, but then I changed it for better accuracy using the coffee can test, which I designed myself.
So the innovation that we looked for was how will our findings make life better for others, make the earth cleaner, how our findings will help the life of an engine, extend it, or just what happens to the life of an engine using biofuels, the ways of making biodiesel more efficient, and also the simplicity of making homemade biodiesel.
So our strategy for project success was to divide and conquer the research and hands-on experimentation between members. And then we developed a research plan and safety protocol. We researched using numerous sources such as books, magazines, videos, interviews, websites, and journal entries. We conducted controlled experiments with the fuels. We created detailed research papers, and we monitored and adjusted the experiments using the engineering design models.
So what I did in my project was I took potassium hydroxide, which is seen right up here. It's commonly known as potash and used usually in a field for fertilizer. And I mixed it with methanol, which in this form was heat. And that's a gasoline engine treatment for solving some of the problems with gumming up. And I mixed the two together in a proportioned amount, and that makes methoxide. And when I mixed the methoxide with the vegetable oil from a deep fryer that I used to make the biodiesel, it produced biodiesel as well as glycerin. Glycerin is a soap, and that's the impurity that is in the oil, and so it basically makes a cleaner biodiesel. So some of the advanced equipment that I used in my experimentation was a LabQuest vernier with a pH sensor and a temperature sensor, as well as a scale accurate to 3 decimal places. So what I did first is an acid-base titration of the oil. That tells me the life of the oil, how much it's been used, because the more it's been used, the more potassium hydroxide I need to add for the chemical reaction to take place. So what I did is I added isopropyl alcohol to the oil and also a pH indicator, and that's all in this container. And in the syringe that I have there, I have a mixture of potassium hydroxide and distilled water that I would carefully put 1/4 milliliter in at a time, and I'd swirl it until it stays pink, like you can see there, for more than 30 seconds. And I did that 3 different times to determine how much extra potassium hydroxide I need to add based on the oil condition. I then took 1 liter of waste vegetable oil right here, and I poured it into a acid jar, a glass acid jar, and I measured the specified amount, the calculated amount of potassium hydroxide that I needed for this experiment. And I then added 200 milliliters of methanol to a glass jar, and I used 200 milliliters because that's 20% by volume of the 1 liter of oil that I initially started with. And then I put the potassium hydroxide into the methanol, and that's seen right here, and it's starting to dissolve. And once it was completely dissolved, I put the methoxide with the oil, and you can see here there's biodiesel on top, and this is the thick layer of glycerin on the bottom. So then after that, I inverted the whole thing so I could let off the glycerin so I could drain it out. And I then started the washing cycle. Now, normally you don't mix water and diesel together, but in this case it helps clean the biodiesel. So I took 500 milliliters of water and I poured it into the diesel, and you can see right here now it's on the bottom and it's not clear like water was when I put it in. It's cloudy, and that's because it picks up glycerin on the way down and it cleans the oil. I then tipped over the jug, let out the water, and I did that 3 more times. So I washed it 4 times. And then I took an aquarium bubbler and stuck it down into the bottom of the diesel to help dry it out, because there still are water molecules trapped. So after I was done with that, I had completed the biodiesel making process, and so I have then my testing. So I took conventional based diesel first, that's the farm diesel, the pink stuff, and I ran it in the diesel engine. This is 10 minutes of data, and in that 10 minutes I started, ran, and stopped the engine. So you can see initially after starting with conventional diesel, there was an immediate drop in the pH, and that tells me that the exhaust is very acidic, and that's common for diesel since it is a very sulfuric type of fuel. And bottom is temperature, and if you compare that to the results from biodiesel, there's not as much of a drop initially, and that's due to the fact that biodiesel doesn't have any sulfur in it. Although both of them do come down to be more acidic, and that's because of the nitrogen oxide gas that's formed when you compress nitrogen and oxygen. So either way, it's still going to bring the pH down since you are compressing those 2 gases, but the biodiesel did not go down as far after starting. And you can see the temperatures are very similar.
So for my experiment, I used a scale accurate to the 3rd decimal place, a Celsius thermometer, the 3 glass burners which held the fuel in them. I used my homemade calorimeter that I made myself, and then I used a stopwatch for timing. So in this picture here is the again the fuel. So I had kerosene, ethanol, and homemade biodiesel in those burners. And then the next picture is of my calorimeter that I made. So the bottom of the pop can is 5 centimeters to the top of the wick so that they'd all be the same distance. And there's 30 milliliters of each of the fuels in the burners. And then in the can is 100 milliliters of room temperature water. So then that is, the 3rd picture is the ethanol burning, the 4th one is the biodiesel, and the last one is kerosene. As you can see, there's a lot of smoke coming off of the kerosene. And then I decided to do the pollution test, which is with this can here. And it is suspended 10 inches from the lip of the can to the floor over the fuels. So the ethanol did not have any particulate matter collected. The biodiesel had more than the ethanol, but the kerosene had the most collected. And then I made some charts, so the averages of all the temperatures that the fuels raised for the water are all up there. So the red is the kerosene, which got to the highest temperature. Blue is ethanol, and then green is the biodiesel, which was at the lowest temperature. And then for my pollution test, I just rated them at ethanol being 0, biodiesel being at a 5, and kerosene being at a 10, which would be the worst.
So what I found mainly when I was testing the biodiesel versus conventional diesel in my engine was that biodiesel was cleaner burning. Although less efficient than conventional based diesel, I did use more biodiesel when I was running it. And this data is shown in the graphs, as well as some visual observations of the engine running. There was less smoke, and the smell was drastically different of the exhaust of both. And I also weighed the diesel before and after burning to determine how much was used.
And for my test, ethanol was the cleanest, but it was less efficient than the kerosene. Kerosene was the most pollutant, but it was the most efficient. And biodiesel was cleaner than kerosene, but it was the least efficient. So in my collected data, I would say that ethanol would be the best option considering price and how much fuel each one used.
So the cost and ease of making biodiesel is feasible, and in furthering the project, we'd like to determine some additives to make biodiesel more user-friendly in cold climates, and we'd also like to advocate for companies to increase the percentage of biodiesel in the warranty coverage. And then we also think that companies should continue to portray or promote ethanol as a viable alternative for fuel.
So some of the questions that we asked during this presentation, during this project were, can biodiesel be easily made at home? And the answer to that is yes, with minimal ingredients and time, because I did it very, very easily. Does biodiesel burn cleaner than conventional diesel? From my testing, yes. By using the lab equipment, biodiesel affected the pH of the water that was that the exhaust was flowing into, less than in conventional based diesel.
Another question is, do biodiesels burn cleaner than kerosene? The answer is yes. In my visual observations and in the coffee filter test, the biodiesel and ethanol contain less particulate matter than the kerosene did.
And then, do biofuels affect engine performance? And the answer is possibly, although more research needs to be done for efficiency and use in cold climates of the fuel. And then, however, biodiesel is more lubricating, so it is better for the engine. So here are a few quotes from professionals that agree with our argument. I connected with John Rosemeyer, and he works with alternative fuels and built an ethanol plant.
I talked to Mr. Kirk Cobb, a senior process design engineer at Superior Process Technologies, and he is currently creating and perfecting biodiesel and the glycerin byproduct. And he gave me some recommendations for making my homemade biodiesel.
We also connected for our research papers that were related to the experimental processes, and they were critiqued by numerous teachers, professors, and renewable energy experts.
And then also the Minnesota Soybean and Research and Promotion Council gave us literature and t-shirts.
And lastly, Justin Miller from Scott Equipment. He's a professional home brewer of biodiesel, and he explained to me the titration process and what's needed, what the equipment is needed for that process. So the application of SOAR that we used, the strengths, all of us were very inquisitive and have strong ties to our Century family farm. And I and Tyler specifically are mechanically inclined. Tyler is very artistic, and Anna is very well organized.
Our opportunities, we have shared our project with professionals in our schools, and we will be presenting at our county fair in August, and we shared in our club. And we have made connections with businesses and presented similar renewable energy projects at local, regional, state, and international science and engineering fairs.
Our aspirations, Brian will double major in mechanical and agricultural engineering, and he's going to start college next year. Anna is interested in renewable energy, and I'm interested in natural resources.
And results, our research and experimentation leads us to believe that biofuels are cleaner for the environment, and in addition, biodiesel can be made easily at home. Here are some sources that we use for our research.
Here are a few more sources that we used.
We also have our entire experimentation documented in research papers and as a photo story, and we'll leave these here and we'll collect them later on. And we will be presenting at our county fair this information, and the boards and research papers were shared with numerous teachers, professionals, and professors for critiques. They're in the back of the binders. We were interviewed by the Mankato Press and Free Press and Land Magazine. Sorry about that. We shared at school with the 4-H Club, and we created a GoFundMe site for large-scale biodiesel making equipment. Thank you.
Any questions?
Are there any questions? Yes.
Grab all you close to each other. So we can we'll share that.
Oh, okay. Should I turn mine off then?
No, keep yours on.
Okay.
My name is Ruth Merrick. I'm with the Minnesota Farm Bureau, and my question has to do with your mentors or mentor. Can you tell me how you worked with your mentor, how your mentor drove you as far as coming up with your kind of the things that you wanted to solve and figure out, and how basically just how you worked with them?
All right.
So she is a science teacher in an educational field, and she really just like helped us push us along, get the research we needed.
Yeah, and she also helped us with getting some of the lab equipment, since she does have connections with the school. So we did borrow some of that equipment from the school because it's very expensive. So she had some ties there that really helped us with our project.
And she also gave us ideas on how to do our research. So.
Yep. Research techniques.
Yep.
Any other questions?
Mark Hammerlake, Minnesota Corn Growers. So regarding you're making your own biodiesel.
Yep.
Had you ever made it before, number one? And secondly, after you completed that, talk to us a little bit about what you think the feasibility for doing that on farm would be from a practical standpoint, actually making biodiesel for farm use.
Right. Okay, so this is the first time that I made biodiesel was for this project, and initially I wanted to buy a farm truck, since we do live on a farm, and run homemade biodiesel in a farm truck. So I didn't get that far. I got to the one-cylinder diesel engine. You got to start small. But as far as the farm feasibility, I think it's very feasible to have farm scale production. Now the really tricky part in Minnesota right now is that we have very cold climate. So in the winter time it wouldn't work quite as well as 100% running biodiesel, but as a blend it would be a phenomenal choice for a farmer. And it's also a lot cheaper to make it. You can make it, if you're really good, at about 70 cents per gallon. I was a little bit higher because I used heat. I used methanol in smaller quantities, so it was more expensive than if you'd buy it in bulk.
I'll follow up on that. I'm just really curious about the washing process there. Yep. I'm sorry, I'm going off topic a little bit, but in standard production of biodiesel, that is part of the process. Is that correct?
Yes.
Okay.